Hello and welcome to the Math 159 Gould Chapter 6 Section 1 video, and this will be about probability distributions. So it's a new chapter, we're in Chapter 6, new thing. Alright, so probability distributions, they're often called PDFs, which means a probability distribution function. So not like the Adobe Acrobat PDF, but PDF as in probability distribution function. Okay, so what are these things? They're actually, you've sort of seen them before. This will be familiar from having learned about probability. First of all, you need a list of all possible outcomes. So if you remember, when we're talking about probability, you need to already have an idea of what all the possible outcomes are. Right? So probability really doesn't apply if you don't know what exactly it is that you might be dealing with. And you also, surprise, surprise, want a probability of those outcomes. So a probability distribution function is a thing which tells you, hey, for this outcome, the probability of that happening is this. So it's actually not that bad, and it's related to stuff that we've already been dealing with. Okay, so there are two types of them. There are discrete probability distributions, and there are continuous probability distributions. So first of all, we need to explain, well, what do we mean by discrete or continuous? So discrete and continuous are two types of numeric variables. So what are the two types of numeric variables? Well, there are, uh-oh, my cursor's not working. No! I wanted to be able to draw with my little, I need to pause this. Okay, well, my little what's it called stopped working, so well, I guess I'll just type everything. So there are two types of numeric variables. There are discrete numeric variables, and there are continuous numerical variables. So what's the difference between them? So let's explain. So there's discrete. Discrete numerical variables count things. So the possible outcomes look like 0, 1, 2, 3, 4, and so on. So the numbers that are possible for a discrete numeric variable are numbers such as 0, 1, 2, 3, 4, and those variables will be counting things. Examples might be, how many siblings does someone have? Number of siblings. Or, how many pairs of shoes do you own? Okay, so those all would be discrete numeric variables because you're counting things. Okay, what's the other type? A continuous numeric variable. These generally measure things. So what sort of numbers can you get? Well, I don't know, like 6 foot 3 inches, or 64.8 kilograms, or 2.78 meters. Okay, can't type kg properly. Okay, these are things which are measured. So unlike discrete variables, which have whole numbers, 0, 1, 2, 3, 4, because you count things, continuous numeric variables will have fractions or decimals. So that's a big difference between them. But if you need to think about the difference between them, continuous variables generally are measured because you can get any sort of decimal, whereas discrete variables, whole numbers because you count things. Okay, so we're going to look at an example of this, of how this works. And we're going to look in particular, let me bring it up, this data set, which is about movie ratings. Again, you can see that there's a variable here which says N poster faces. So what these are, you can see the titles. So Batman vs. Superman in the year 2016. It was 183 minutes long with this rating, and then who the director was, what country it was released in, the language it's in, the aspect ratio, and then this one's a really interesting variable, N_poster faces. What this is the number of faces on the movie posters. When they're advertising movie posters, they... let me pause this. Sorry for the interruption. So anyways, we were talking about the data here. So we have the number of faces on the movie poster. So Batman vs. Superman, according to this, had 0 faces on the poster, whereas Star Trek Beyond had 4 faces. So we're going to look at that distribution. So let me go back to the notes here. So how you display and work with a a probability distribution function depends on whether the numeric variable is discrete or continuous. So we're first going to deal with discrete or continuous distributions. So our first thing here will be discrete probability distribution functions. So if you're dealing with discrete probability distribution functions, there's two ways to show the probability distribution function. One as a graph, and two as a table. So we're going to go into StatCrunch and look at this. So it's actually pretty easy. So let's do the table first. So you have a numeric variable, and we want to make a table of it. So you go stat, tables, frequency table, and you choose the variable and poster faces. Click compute. There's our probability distribution function. So what is the chance of encountering a movie poster with 0 faces on it? Apparently approximately about 42%. What's the chance of encountering a probability distribution, what's the chance of encountering a movie poster with 2 faces? About 14%. So you can actually see, if we sort this by relative frequency, more faces are less common. So the table is pretty straightforward. You can also make a graph. So go over here to graph, and we'll make a bar plot with data. We'll choose number of poster faces, and then you have some options here. It says order by. So you can order by value. Order by value. So you can see how it goes 0, 1, 2, 3, 4, 5, 6, 7, and so on. So that's the order by value. You're ordering it by how many faces you see on the poster. And if you hover, this is literally just the table in graphical form. You can hover over this. You can see that it says, the frequency, the number of movie posters with 0 faces is 2,112, and you can see over here that's a 42% chance. So the height of these bars is relative to how likely those things are. You can go back, edit, and you can do value by. Alright, so you can do, instead of value ascending, you can do count ascending. So what that does is actually it sorts it by, let me go back to edit, count descending. This actually ranks it by probability, but in this case you can see that, well, like for instance right here you can see that 15 faces is a little more likely than 11 faces. Okay, so you can choose how you're going to order it. Okay, so those two are pretty easy to deal with. The third way, and so you basically would use the data in StatCrunch. You'd go and you'd make a graph, you'd make a table, and you can answer the questions that way. The third way, which is a little more difficult, is when you have an equation. So I'll explain this one with an example. So let's say that you're rolling a 6-sided die, also known as D6, a die with 6 sides. Okay, so from this, we know that the probability of any number is 1/6, right? Because it's a fair die. So let's say you were rolling this fair die, and you're playing a game. And let me explain the game to you as follows. If you roll a 5 or a 6, you win $4. If you roll a 1, you lose $5. And then finally, if you roll a 2, 3, or 4, you get and lose nothing. So you can see there's several different outcomes here, right? If you roll a 5 or a 6, you win money. If you roll a 1, you lose money. If you roll a 2, 3, or 4, nothing happens, basically. Okay, so we're going to just make a table of this because we're sort of using an equation here, right? We're using the fact that the probability of any of the outcomes is 1/6, but the outcome we're interested in is not the roll of the die itself, it's how much money you win. Okay, so the outcome we're dealing with here is how much money you're winning. So we want to know what's the chance of winning $4. So I'm going to put +4. We want to know what's the probability of losing $5. And we want to know the chance of nothing happening, $0. So, well, we have to then look at correspondingly what will happen with the die. Oh no, I have to copy those over. So I put this here. Okay, there, let me re-put everything. Okay, so +4, -5, and then +0. Okay, let's get rid of this one. Okay, so when do you win 4 if the roll's a 5 or a 6? When do you get -5? When you roll a 1? When do you get 0, a 2, a 3, or a 4? Okay, so insert right. So there we go. So here's the probability. Okay, so the probability of getting $4 is the probability of 5 or 6, and we've learned how to do this in the past, right? We have literally a bunch of it's not letting me. Okay, we know how to calculate this probability because this is calculating a probability with an OR with equally likely outcomes, and they're mutually exclusive. Rolling a 5 and a 6 cannot happen at the same time, so we know this is the same thing as rolling a 5 plus the probability of rolling a 6. If you go back to the formula we had for calculating mutually exclusive outcomes, we know that if they're OR, you just add them together. So what is that? That's 1/6 plus 1/6, which is 33%. About 33%. 33.33%. What's the chance of losing $5? The probability of rolling a 1, which we know is 1/6, which is about 16.67%. And then for the last one, it's the probability of rolling a 2 or a 3 or a 4, which, because they're mutually exclusive, you can just simply add them together. Which is 1/6 plus 1/6 plus 1/6, which is 50%. So here we have made our probability distribution function, sorry, simply by taking the equation we had, which was we know that the chance of rolling any number was 1/6, and then using our probability rules to calculate the probabilities of these outcomes. So remember, I'm not concerned about what happens if I roll a 5 or a 6. I want to know what's the chance that I win $4, 33% about. What's the chance that I lose $5, about 16%. What's the chance that nothing basically happens, 50%. Alright, and that's our first video about discrete probability functions. I'll talk about continuous probability functions in the next video.